Hello everyone, my name is Don. Thank you for joining me on this Americans with Disabilities Act ramp class. Today I'm going to focus on the main elements of these ramps such as ramp running slope grades, wing grades, landings, gutter pan, and gutter slopes. I hope this will answer some of the questions you might have. This information will be helpful for guiding you into design, inspection, and construction. This will be Class 1. I plan to develop a Class 2 which will show you how to apply these guidelines into a plan and profile civil 3D design project. So sit back, enjoy, and we will get started. First, I would like to start off with a little history. Back in the year of 2012 and 2013, DOJ and DOT, FHWA came together and came up with a joint technical assistance guidance that would determine the difference between alterations projects versus maintenance projects. This would dictate if you were required to reconstruct older ramps that did not follow current Americans with Disabilities Act compliant guidelines. If your project was considered a maintenance application only, you will not be required to do improvements such as new curb ramps or the reconstruction of older ramps. This list will show you the difference between maintenance and alteration projects. Often if you combine some of these maintenance applications, it would jump you into an alteration. Such as if you had a chip seal plus a slurry seal, that would jump you into an alteration application, which would be considered a cape seal. The cape seal would be considered a maintenance application. Maintenance projects would include a chip seal, crack filling, fog seals, joint repairs, pavement patching, slurry seals, and others listed above do not require you to reconstruct, update, or install new curb ramps. Alterations projects will include new construction, adding a thin layer of asphalt over an existing road. Cape seals, hot-in-place recycling, mill and fill, and others listed below would require you to install new ramps. Alteration project will require you to update older ramps per Americans with Disabilities Act compliant guidelines. Many people ask why are they reconstructing a new ramp when this existing ramp looks perfectly fine. I wanted to bring this original standard detail into this presentation so I could show everyone that many of the items are no longer compliant and do not follow Americans with Disabilities Act guidelines. This was the original curb ramp detail that had been constructed up until the year 2005. I will point out a few items that are not compliant with Americans Disabilities Act, such as grooving is no longer used around the top edge or the ramp. The 1-inch lip along the front of the gutter pan cannot be used any longer. On this detail, they show 5-foot wings as a standard dimension. The wings now need to be 9% max. The landing at the top of the ramp did not show a grade of 1.5% max in either direction, or a distance showing the length or width of the landing. The only grade that can currently be used on this detail is the ramp run slope itself at 8.33%. But even this slope is the maximum as build slope and was often constructed over these limits. If you have one of these ramps on your projects, it will be very difficult to modify the grades, wings, and landings to make them compliant. Your final constructed project will look much nicer and be easier for construction if you just remove them and replace them with a new compliant ramp detail. Okay, let's get started. Off to the right of this slide, you'll see the acceptable as-built grades where max grades are listed. These are as-built grades and should not be used for your design grades. After construction, if a ramp has been built below these as-built grades, they can be acceptable. If they are over these listed grades, the ramp will need to be removed. So please remember, during your design and construction, we will use the lower grades to the left. If you find yourself in a situation where you have no other alternative but to design close to these as build grades, please note them on your design plan so the contractor and field engineer can pay special attention to these ramps during construction. Ramp running slope are normally designed at 7.5%. This way during construction, you will not be over the 8.33% allowable as built construction. Cross slopes and landings are locations where you would maneuver a wheelchair. This landing should be designed and constructed at 1.5% max in either direction. The maximum acceptable as build grade will be 2%. Flares and wings are located at front of a ramp. When designing a wing, your normal wing would be around 9% max. The maximum acceptable as build grade will be 10%. During and after construction, the measurement and grades will be field verified in multiple locations to assure that they are not over the maximum acceptable as build grade. A quick overview. A ramp run slope should be designed and constructed no steeper than 7.5% maximum. Top landing should be designed with a cross slope in either direction no steeper than 1.5% maximum. Flares and wings should be designed and constructed no steeper than 9% maximum. As discussed earlier, after construction of your compliant ramp, the inspector during final inspection will use a 2-foot smart level and field check these ramps in multiple locations to verify grade and width. This is a copy of our Americans with Disabilities Act compliant ramp guidance policy. As noted above, you will be designing your new ramps with the maximum conservative slopes of 7.5%, 1.5%, 9%, and etc. If a higher design slope is needed but does not surpass build maximum limits, the designer will need a field survey of the existing conditions and a detailed ramp design showing all elevations and all slope at all points. A note to the resident engineer will also be required prior to construction. After placement, the acceptable construction phase for these grades has an additional allowance of 0.2% deviation that can be due to instrumentation error measurement. Therefore, measured slope should be maximum after construction of 7.7%, 1.7%, and 9.2%. If measurements are higher than slopes that include conservative slope plus instrumentation error, but less than maximum as build requirements, the resident engineer should confer with Americans with Disabilities Coordinator staff. Acceptance with Americans with Disabilities Act. Criteria for constructed ramps may be allowed even though it might be outside of the contract compliant if it does not exceed max as build slopes. Caltrans standard 88A and 88B are normally used for a ramp design. As we go through these details, you notice they do not list as build grade. We have found out during the years of construction and design, if you have a detail using the maximum acceptable as build grades, the contractor will use them. Concrete tends to swell, ultimately a portion or portions of the ramp being over the acceptable grade limits that will require removal and reconstruction. It is always better to incorporate a little wiggle room in your design, and it is never fun to argue with a contractor telling them they need to remove a ramp because it is slightly over the acceptable as build grades. Caltrans standard A88B are normally directional ramps. These ramp details also follow these guidelines. There are 5 major concerns when designing, constructing, and inspecting an Americans with Disabilities Act ramp. Many of these grades we have already discussed, but I will be adding a few more key items. Ramp run slopes, flares, wings, and top landing. Item number 1. This is your main control of your compliant ramp design. Everything will be designed and constructed from these elements, so it is very important to have these correct. The ramp running slope should be designed no steeper than 7.5%. Wings and flares should be designed no steeper than 9%, and your ramp landing should be no steeper than 1.5% in either direct. Caltrans Case A ramp has a 4-foot 2-inch wide minimal width. The upper landing is also 4-foot 2-inch minimal width. We have changed this for all our future design to 5 feet minimum. As we go through this class, I'll show you the reason why. Top landing item number 2. These sections represent a grade going through the ramp itself. Caltrans standard 88A Case A ramp will have a section that looks like Section A. Caltrans Case B ramp will have a section that looks like Section BB. And Caltrans Case C ramp will have a section that looks like Section CC. Selecting the correct ramp you plan to construct will depend upon many constraints you have within the road intersection, such as existing right-of-way and/or physical obstructions. I normally begin with a Case A ramp and then work my way down the sections if needed. I believe the Case A ramp is better than a Case B ramp. Then the Case B ramp is better than a Case C ramp. I will show you why. With a Case A ramp, the normal ramp running length will be approximately 10.8 feet. The WS on this detail will stand for water surface elevation of a typical 25-year rainstorm event. Normally, we try to design our roads to convey a 25-year rainstorm event from top of curb. On a normal 25-year storm rain event, your landing will be above the water surface, keeping the ramp open and somewhat dry for pedestrian use. I understand this is a photo of a driveway, but this driveway will show you the water surface of a typical rain event. As you can see, the water surface is close to the existing top of curb. The back of this driveway would be very close to the same elevations as a Case A ramp landing. Constructing a Caltrans Case A, Section A, will allow the landing to be accessible and help with the erosion and settlement buildup. The Case A and Case B ramps are much easier to maintain and keep clean after a storm event because they do not trap as much sediment as the Case C ramp. As you move down the list of Caltrans sections to the Case B ramp, Section BB, Case B ramp have some great advantages. You can increase the ramp running length to work as if it were a Case A ramp, or reduce this length to fit your right-of-way or obstruction as needed. The concrete curb in the back of the top landing is optional. As you can see, if you reduce the ramp running length, the water surface will begin to encroach onto the upper landing. Moving down the section to the Caltrans Case C ramp, Section CC. The advantages you will have with this style ramp is requiring less right-of-way for construction. You will sacrifice the water surface elevation, keeping the landing and ramp usable during any type of storm event. You will receive more sediment buildup on a Case C ramp, Section CC. Truthfully, we construct many Case C ramps because it requires no right-of-way, or much less right-of-way than all the other ramps. One thing you need to keep in mind is San Bernardino County Standard 302. If you design a ramp with a block wall or other obstruction, the minimal distance behind the landing needs to be 5 feet minimal. Caltrans does not show this on their detail, but if you have an obstruction such as a block wall, 5-foot minimal for the length of the landing will be required. I would like to point out that a Caltrans Case C, Section CC, has been revised to 6-foot wide minimal. Also, the Caltrans Case CM and Case CH ramps have also been revised to 6 feet wide minimal. The reason for increasing this width was needed for a wheelchair will have the correct room to turn. With this distance, the wheels should not be located and restrained on the raised truncated domes. This will allow wheelchair approximately 3 feet for turning movements outside the truncated domes. If needed, some exceptions to this requirement can be modified. If you do not have a proper right-of-way and it is technically infeasible, this 3-foot surface can be reduced to 2 feet, making the ramp width 5 feet. I would like to go over this quickly one more time. The Caltrans Case A ramp, Section A ramp, will have less maintenance, less storm water ponding, but will require more right-of-way. The Caltrans Case B ramp will require less right-of-way than a Case A, but you might have a little bit more storm water ponding and a little bit more sediment buildup depending on the ramp run length. The Caltrans Case C ramp, Section CC, will have more debris and storm water ponding, but this ramp requires much less right-of-way than a Caltrans Case A or Case B. And remember, if you design a ramp or construct a ramp that has a block wall or obstruction behind the landing, this will require 5 feet minimal distance. This is a Case CH ramp, but a Case C ramp will pond water close to the same. As you can see, the water ponds over the ramp itself, making this unusable during a storm event. Now on to item number 3, gutter pan and street gutter slope. The gutter pan and street gutter slope are located at the beginning of the ramp. This is necessary so a wheelchair can be in correct line before climbing the ramp running slope. Per Caltrans standard, the gutter pan is not to exceed 1 inch per every 2 feet, or 4.16%. And should have a crossfall of no steeper than 1.5% maximum. 2 feet beyond the lip of the gutter should be no steeper than 5% maximum and should have a crossfall no steeper than 1.5% maximum. ProWag makes this a little easier. They consider the first 4-foot length to have a maximum grade of 5% and a crossfall no steeper than 1.5% maximum. The width should be the same as the ramp, with a minimal distance of 4 feet 2 inches. I have been informed that some directional ramps will allow 2 feet in length with 5% maximum grade and a crossfall of no steeper than 1.5% maximum if the field conditions do not allow 4 feet in length. If a wheelchair does not need to adjust for a change direction, this can be acceptable. Please consult your Americans with Disabilities consultant to verify this will be adequate for your project. Transition pads, note number 9, will be the 3 feet plus on either side of the gutter pan. Caltrans notes this should be 1 inch for every 2 feet, or 4.16% maximum. Now we are on to conforming slabs, item number 4. Conforming slabs can be a little difficult to understand and can be very controversial. Caltrans Case A considers the conforming slabs to be left and right of the top of the landing. The Caltrans grading checking list notes this can be no steep than 5% or if adjacent to the roadway and sidewalk grade does not exceed the roadway grade. This is where things get confusing. If you place a ramp on a typical curved intersection, the face of curb will always be longer than the back of the sidewalk. The roadway grade will be flatter than the sidewalk grade. You will have relatively the same elevations from the top of curb to the back of sidewalk, but different lengths. This is a standard rise over run calculation. The back grade and where these conforming slabs are located will always be steeper than the adjacent roadway. If you review Caltrans standard at 88A, Case A, this area is shown to be a sidewalk. Per CBC, sidewalks are not subject to 5% max and are allowed to be general grade established for the adjacent streets. Per DOJ, sidewalks contained within the street or highway right-of-way. The grade of the pedestrian access route is permitted to equal the general grade established for the adjacent streets, typically the roadway geometry. The key words are the general grade established for the adjacent streets. And this is the controversial part. DOJ, CBC, and the Caltrans standard Case A detail labeled sidewalk conflict with Caltrans conforming slabs requirement noted on their grading checklist at a max of 5%. I'm sorry, I know this is confusing. Hopefully when I explain the Caltrans Case B ramp, you will be able to see the difference and this will help. On the Case B ramp, the conforming slabs are located just right and left of the BCR and ECR. Per Caltrans Case A ramp, The conforming slabs left and right should not be over 5% maximum when joining existing sidewalk elevations at the ECR and BCR. But when you construct a Case B ramp, these grades can be designed up to 7.5% maximum or as build grade to 8.33%. The only difference between a Case A and a Case B ramp is that the Case A ramp has a different placement of the conforming slab. The Case A ramp also has a ramp and landing that is 4 feet 2 inch wide minimal. The Case B ramp and landing are 5 foot wide with the conforming slabs at the ECR and BCR. To me, this makes sense because the conforming slabs are to be adjacent to the roadway and the sidewalk grade is parallel with the road so it will not exceed the roadway grade. We have come to the conclusions that all ramps and landings will now be constructed at 5 foot wide minimal. This will give us the option, if necessary, to construct these ramps at 7.5% maximum or as an as-built construction of 8.33% max. This can be very confusing, so I thought a visual design could help. The conforming slabs on a Case A ramp would require to be 5% max. Below is Caltrans Case B. The ramp and the landing both are 5 foot wide minimal. We would normally design these side ramps right and left to 7.5% max, but in an as-built situation, they could be constructed up to 8.33%. The conforming slabs are located right and left of the BCR and ECR. As you can see with the Case B ramps, this will allow you more room for modifications in the field and design if needed. Okay, I hope I haven't lost anyone with all of that. We are close to the end. Let's do a quick quiz. Yeah, I hate quizzes too. Let's just do this quickly. All these slopes will be your design maximum slopes. On a Case A ramp, what is the max ramp running slope? The correct answer is 7.5%. And ProWag has a minimum running slope of 5%. What is the maximum top landing grade and minimum length? The correct answer is 1.5% in either direction with a 4 feet 2 inches long landing. 5 minimum if you have a block wall or other obstruction. What is the maximum gutter pan crossfall? The correct answer is 1.5%. What is the maximum gutter pan running slope? The correct answer is 5%. What is the maximum gutter pan transition slope? The correct answer is 4.16%. What is our minimal ramp width and landing? The correct answer is 5 feet. What is Caltrans conforming slab grade? The correct answer is 5% calculated at the back of the sidewalk. What is DOJ and CBC conforming slab grade? The correct answer is the general grade established for the adjacent streets. Now let's go over a Case B ramp. All ramps have the same maximum top landing grade, ramp running slopes, wings, gutter pan, and transition slope. But what is the maximum ramp left and right grade? The correct answer is 7.5% calculated at the back of the sidewalk. What is the distance of the ramp running slope? The correct answer is, this distance varies depending on your right-of-way. What are the conforming slab grades left and right? The correct answer is 5% maximum or existing grade from adjacent streets. These are located just before the BCR and after the ECR. The last ramp we will do is a Caltrans Case C ramp. What is the ramp right and left grades? The correct answer is the ramp left and right grades will be 7.5% maximum and measured at the back of the ramp. Remember, if you use the 7.5% at the front of this style ramp, the back would be over maximum as build grade and would need to be removed. What is the landing grade? The correct answer is the landing grade will be 1.5% in either direction and will have a length of 6. What are the conforming slab grades just before the BCR and end of ECR? The correct answer is 5% maximum or existing grade from adjacent street grade. Now you have a great foundation and you will be ready to begin your new ramp design. They have a few items you might want to be aware of, such as we have discussed the Caltrans Case B ramp many times throughout this video. I would like to bring up one more possible design element you might be able to use on your design or construction. We all know by now per Caltrans the ramp slopes left and right on a Case B ramp is 7.5%. This will allow you more modifications and adjustments in the field and for design. This also brings up a good question about general grade versus running slope. Running slope is a slope of the ramp. Ramp running slope can be either horizontal or perpendicular. ProWag and Caltrans both have a condition that says if you cannot meet your running slope grade, typically 7.5% max, you only need to go out from your landing 15 feet to meet the existing surface. This is the only time the running slope can be over the as-built 8.33%. I normally avoid this whenever possible when designing a running slope grade, but it is an acceptable solution and normally only used for mountain roads. Now the question has come up on a Case B ramp. The ramp right and left, as noted per Caltrans grading sheet, represents this to be a ramp. These ramps are required to construct as part of the Case B ramp itself. I believe this could be considered a perpendicular running slope of a ramp, and the 15-foot rule for these ramps would be acceptable if needed. Please consult your Americans with Disabilities specialist before constructing or designing this type of ramp using the 15-foot maximum as a guideline. Now general grades are different. They are sidewalks and pedestrian access routes within the existing right-of-way. General grades are established from adjacent street and/or highways and are not subject to the 5% maximum grade policy. If you have a pedestrian walkway outside of the public right-of-way, this walkway cannot be over 5% maximum. Last but not least, I need to mention a little about raised detectable warning surfaces. Detectable warnings are a distinctive surface pattern of domes detectable by cane or underfoot that alert people with vision impairments of their approach to street crossings and hazardous drop-offs. Detectable warning surfaces are normally placed at the beginning of ramp entering the roadway. If you have a directional ramp, the minimal distance is 5 feet from the back of curb. Question: do you install a detectable warning surface at driveways, with the exception for signalized driveways or few other cases? The use of detectable warning surfaces, such as truncated domes, is discouraged because overuse of datable warning surfaces may make it more difficult for pedestrians with vision impairment to recognize streets and to maintain their orientation. Lessons learned. Remember to always design your curb returns with the required curb return radius. Each jurisdiction will have a recommended curve radius chart. You should never design any radius below the minimal standard. Truck, trailers, and cars often drive over the curbs and can be very dangerous for pedestrians. The next time you are out and driving around, review all the black tire marks on a concrete curb. When building ramps in a snow area, the vertical curb ramp should not be used. The curb and ramp can be damaged if the blade of the snowplow hits the blunt end of the curb. It can also damage the plow itself. These ramps should always be designed with a wing so there is no blunt end. I have also noticed when designing a curb-style ramp that the downhill side of a cross-gutter will always divert more water and silt onto the ramp. I believe a good alternative to this is design the downhill side with a flare so it will divert most of the flows and silt backing the road. As you can see with this video, a lot of water is diverted back up the ramp and onto private property. To help this problem, adding a concrete wing with rock will help divert most of the flows back into the street. Okay, congratulations to everyone that made it to the end of this video. I know this was a very long class and I hope you were able to find some useful information before starting your new project. I plan to create a future part 2 of this video, showing you how to apply these requirements to a civil 3D curb ramp design, plan and profile. Thank you again and have a great day.